Today we're going to look at balancing half reactions. There are 8 steps for balancing a half reaction. First, you want to split into oxidation and reduction half reactions. Balance all but the H and O. Balance O by adding water. Then you balance the H by adding the H plus on each half reaction. Balance the total charge. Then you equalize the electrons by making sure they're equal, the amount being oxidized and reduced. Transferred has to be equal. Add them up, cancel out the electrons, and then you're going to add hydroxide ions for each hydrogen ion if the reaction is happening in a base. So these are the steps that we're going to go through, and we'll do a sample problem of how to do that. It's always important to make sure the atoms are equal and the charge is equal for balancing a redox. So here's iron 2 chloride and potassium dichromate. Solutions are mixed. First, we want to write and identify the half reactions. These will normally be given to you. So let's look at this. Here's the reaction, not balanced. So what we need to do is identify the oxidation numbers of each of the substances. So if we look at the iron, it's got a 2+ charge, so it's going to have a +2. Iron on the right side has a 3+ charge, and the chromium on the right side is a +3. Oxygen is -2, but chromium on the left side has a +6. So the question is, well, how did we get that +6? Well, you've got 7 of the oxide ions with -2 charge, and you add that to the chromium's charge, and it should equal a total charge of 2 negative, because that's the ion charge of the whole ion. So what would be added to -14 to equal -2? That should be +12. And since there's 2 chromiums, you divide that by 2, and that gives us the oxidation number of the individual chromium on the left side. So the oxidation reaction, you can notice, is the iron is being oxidized because it's losing electrons, going from 2+ to 3+, and the chromium is being reduced. Now, the chromium in the chromium oxide is being reduced to the chromium 3+ on the right side. So it's the +6 going to +3 oxidation number that tells us that it is being reduced in its oxidation number. So that's called reducing the oxidation number. That's an important thing of identifying what's being oxidized and reduced. So once you have these, the next step is to balance all elements except O and H. So we look here, Fe, Fe, those are balanced. Cr2, Cr, not balanced. So we need to add how many Crs to the right side? That's right, add 2 of those, so we now have the balanced. Next step is to balance all O's by adding the H2O's. So in the first one, no O's. Second one, there's how many O's? Yep, 7. So you add 7 waters to the right side. That balances out the O's. Next step is to balance all H's by adding H pluses. So we have no H's in the first reaction. Second half reaction is 7 times 2, 14 H's on the right side. So we need how many H pluses on the left? So we've completed step number 4. We got the 14 H pluses. Now we need to balance the total charge by adding electrons for each half reaction. So for the first one, we start with a 2+ charge, we go to a 3+ charge. It's going through oxidation, so it's losing electrons. The number of electrons it's losing to go from 2+ to 3+ is 1 electron. So now the charge is balanced on that first half reaction. On the second one, we've got to add up the charge and figure out how to balance the charge on the second half reaction. how many electrons do we need? First we add up the 14 positives plus the 2 negatives. That gives us 12 positive total. And then on the right side, it's 2 times positive 3, giving us a 6 positive on the right. In order to make these two balanced or equal on the left and right, we have to add how many electrons to the left side? 6 electrons. 6 negative plus 12 positive equals 6 positive. So now we've done step number 5, balancing the total charge by adding electrons. We have 6 electrons on the left, but we only have 1 electron total on the right. So the next step is to equalize the number of electrons on each side of these two individual half reactions. So to do that, we would need to have 6 electrons in the first half reaction. So we multiply the whole entire half reaction by 6. And that changes the 1 electron to 6 electrons. So the top and the bottom have equalized electrons. So the next step is to add the half reactions together. So everything that's on the left gets added up, everything on the right gets added up. And then you cancel out electrons and any species that appear in both the left and right side. So in this case, the electrons cancel. There's nothing else that is exactly the same on each side. If the reaction is in acid or an acidified solution, you are done with balancing the redox reaction. If it's not in an acid solution, that means it would be in a basic solution. So if it's in a basic solution, you would have to add OH to both sides of the equation for the same amount of hydrogen ions. So you need 14 OHs on the left, 14 OHs on the right, hydroxide ions on the right. When you add an H and an OH together, it makes water. So now you have 14 waters on the left. And on the right, you have 7 waters plus 14 hydroxides. So when you have the same thing on the left and the right, you have to cancel them out. So next we cancel out the waters. There's 7 waters canceled out. And this here is then the final equation for a basic solution. So this is a different equation now to try to balance using the rules of balancing redox equations that we just used. You want to complete this reaction for practice. Thanks for listening. We'll see you later.